Joe Doliner works on Pachyderm.io, a containerized data analytics platform that seeks to rebuild Hadoop from scratch. Joe, welcome to Software Engineering Daily.
Jeff, thanks, man. It's great to be here.
So back in February, your colleague Joey Zwicker wrote a manifesto called Let's Build a Modern Hadoop. What is outdated about Hadoop?
So I think a number of things are outdated about Hadoop. The single biggest one, though, is the open source community that's around it. Hadoop as a software project is sort of driven by a million different companies that all have a million different goals. And so you don't get this cohesive API. You don't get a cohesive product that's really fun to use. I come from a background in databases. Before this, I was actually working at RethinkDB. And I saw firsthand how important it is to have a full cohesive product that was designed by one company that can be really compelling for people in their use cases. So that's sort of at a high level what I think is outdated about Hadoop. From a software engineering level, I think what's outdated about Hadoop is that they basically had to create all of the distributed systems code from scratch to build it, because nothing like that existed now. So they have their own schedulers, right? They have their own discovery services and Zookeeper. All of these things are generic distributed systems primitives that you want to have somebody who's really dedicated to making them good and making them just sort of generic and good for general use cases. So in our system, we have a ton of off-the-shelf distributed primitives that we get to use. We get to use Docker containers. We get to use etcd. We get to use Kubernetes, which is, of course, a scheduler from Google. All of these are really, really good at covering that use case. And so we can tie them together into something that can nail our use case.
Interesting. So one interesting quote from that manifesto is that Facebook forked Hadoop 6 years ago and have since kept it closed source. And in the interest of motivating this conversation, what was Facebook's reasoning for forking Hadoop?
So we actually had a meeting. We've had meetings with several Facebook people where we talk about their fork of Hadoop. There wasn't one single sort of compelling reason. It was really just like a bunch of little things that didn't quite fit their use case. And like they just needed to have control over all of those little things for it to really be usable for them. But things sort of just slowly drifted apart. And when you talk to them about why they can't merge the things together, like there's no big like ideological difference. It's just that this would just be too many man hours at this point.
So essentially what you're saying is that this ecosystem has gotten so big and so fractured that this is what calls for starting over from scratch.
Absolutely, yes. And so to give you a very concrete example of this, I actually have some experience running Hadoop at AirBnB. And when we were running Hadoop there, we experienced a huge number of outages that came from Zookeeper, which is the sort of discovery backbone of the Hadoop ecosystem. And despite the fact that these problems were really killing us, there was really nobody that we could talk to about fixing Zookeeper because it's no company has like Zookeeper as their product. And so nobody really has an incentive to improve it because if you improve Zookeeper, you're improving your competitors' offerings as much as you're improving your own. And so these things just never get fixed and they never get really good.
Why is Zookeeper so tightly coupled to Hadoop?
Zookeeper is tightly coupled to Hadoop basically because they've been in close proximity for a very long time. And so like little specific features that Hadoop needs have crept into Zookeeper, and it's at this point just like a little bit too much work to tease them apart. There's sort of a little bit too much path dependence is the phrase I've often heard for this. That you pick a path in software, you go down it, and even if you think you have like these two modules that are separate, at the end of the day you realize that like the API line isn't quite clean enough between them that you can just swap one out and bring in a new component.
There's been a lot of development in container technologies in the past few years. How does the traditional Hadoop ecosystem interact with containers?
So right now, the traditional Hadoop ecosystem doesn't interact very well with containers. And the reason for that is because as soon as you start trying to containerize Hadoop, you realize that you've sort of got these two competing systems for everything. And what you wind up doing is sort of deploying Zookeeper inside of Docker containers that are discovering each other via etcd and like scheduling Yarn in a container so that it can schedule other things within things. And you've got, schedulers inside of schedulers and discovery services discovering discovery services. And you sort of just wind up with a huge amount of overhead that you have to handle, and that's really what kills you.
So now that we understand some of the things wrong with Hadoop, what are you building at Pachyderm?
What are we building at Pachyderm? So the broad sort of type of product that we're building is what we're calling a data lake. This is the way that people really use Hadoop in production today. Is it's basically just this like gigantic swath of storage that anyone in the company can just dump data into. And this comes from like logs from websites. This comes from like payment trails from things. A million different things get dumped into here. And then you want a system that can store all of this elastically and then give you a way to compute things over it after the fact so you can learn from it. So at Pachyderm, we have, first and foremost, a file system that's designed for storing this data. This is called the Pachyderm File System, or PFS. It's sort of isomorphic to the Hdfs, the Hadoop file system in the Hadoop ecosystem. But it has one very, very big difference in terms of how it thinks of data, which is that we think of data in a commit-based way. And by commit-based, I mean something very similar to Git. So in Git, right, you have a repository of code, and then you have all of these commits within the repository that are basically a snapshot of what the code looked like at a certain point in time. We do that for petabytes of data. So you can just dump data into our system and then take commits of it that give you a snapshot of what your data looked like at a specific point in time. Does that make sense?
Absolutely. And during Data Science Week, which was last week, we interviewed several people who are working on large data science projects, including the CTO of Kaggle. And one of the things that he said was that data science needs version control. Like, we need version control for large amounts of data. So is that one of the use case, or maybe that's exactly the use case that you just described?
Yeah, absolutely. So you need version control for data. And actually, I know the CTO of Kaggle too, and we've talked about version control for data a bunch, and he really gets all of the ways that that's going to be impactful for data science. But basically, the reason that you need version control for data is the way that the people in a company access data is inherently collaborative, right? And you'll have like all of this data gets dumped in, and you don't really know who's going to use it. At Airbnb, we set up Hadoop. And we're thinking this is a tool for sort of maybe our engineers because it's pretty technical. It's a tool for data scientists. But we had people on the marketing team just show up and say, like, look, guys, I need to use this data because this data is just so valuable. This data lets me make decisions. And so we wound up with just sort of a million different hands in the pie because everybody wanted to touch a different piece of data. And this got to be really, really contentious because if you're doing analysis on data, you don't want it to change. Like, you don't want to come in tomorrow morning and find that the analysis you're running was in some way broken. Because
but if you're doing data science, isn't that mostly a read-only operation?
It often is not, because often sort of the intermediate steps, what you need to do is like transform some data set into like a clean form. Like if you want to compute something over users, maybe you want to like discount all of the users that haven't actually like purchased anything. So you sort of like cull this down to like a distilled form of users. And people make these little changes, and they really wanted them to be there to have just like something that they knew no one else was going to change. And so what this sort of degenerated to in Airbnb is I'd come in to look at Hdfs, and we would have Jim _users, Steve _users, Tom _users, which is each one is just a copy of Tibble. And so there's a ton of reasons why this is bad. One is that this actually wound up wasting a ton of space and was hard to figure out. The other, though, is that now you suddenly at your company don't really have a unified idea of what users means. And so you have like this one piece of analysis that one person wrote that says like, we have this number of users and they're sort of like, this is growing at this percent. And then another one is writing something about that those users, but he has a different total number of users. And it gets very, very hard to reconcile what the truth is. And the sort of end result of this is that if the data science you're outputting doesn't have this consistency in it, people stop trusting it. Right? Because if an executive gets these two conflicting reports and they don't know which one to trust, then they're just like, okay, like I need to be able to make decisions quickly And this is confusing, so then they wind up going with gut instincts.
Very interesting. So, okay, we've talked some about the motivation for Hadoop switching to a totally different model. Let's dive into the guts a little deeper and compare Hadoop to the spec for Pachyderm, or what you have at Pachyderm. So at the bottom of the Hadoop stack, you've got the Linux kernel. And a Hadoop cluster is managed by Apache tools like Yarn and Zookeeper.
Yep.
And then you've got distributed storage, which is handled by Hdfs. And then the job platform is the JVM. And distributed processing is handled by Hadoop MapReduce. So from those components that I just described, what is the Pachyderm stack replacing?
So what is the Pachyderm stack replacing? We're certainly not replacing the Linux kernel. I would expect you to laugh me off the show if I said, well, step one is the kernel.
Such a coward.
Yeah. Sorry, this is the cowardly version of. So what we are replacing there, first off, we're completely replacing the JVM, and we're basically replacing the JVM with Docker. This is sort of a huge switch that I wanted to make. First off, I've never been a huge fan of Java. It's never really resonated with me. I've never loved developing software in Java. One of the things that I hated about Hadoop is the fact that you basically have to use Java to really use it effectively. There are kind of ways around it, but at the end of the day, you're always going to have to wind up writing Java. In our system, because Docker is our job layer, it means that users can use whatever tools they want. If you want to include some esoteric open source library, you can still just put that in a Docker container, and then our job platform can distribute that out to your data and make it a parallelized operation. So let's go through these sort of, I think we want to go through specifically and like match up what things in the different architectures really go together. So they have the base layer of Hdfs. These are basically Java applications that are deployed. I believe you basically just sort of like run these on VMs, is the way that people normally do it. For us, we have everything inside of containers, which means that out of the box, users of Pachyderm don't even have to deal directly with VMs in like GCE or AWS. You can actually deploy Pachyderm directly on top of Google Container Service, which means you can just like have this very clean system where you can elastically scale up and down the number of physical nodes you have, and Pachyderm really doesn't have to be aware of that.
Are there other components of Pachyderm that you haven't mentioned yet that are replacing parts of the Hadoop stack?
Yep. So there is the Pachyderm file system that replaces HDFS. Then the other major component that we haven't talked about yet is the Pachyderm pipeline system. This is the equivalent of Hadoop MapReduce. This is the thing that lets you actually run computations over the data that is stored inside of PFS.
Right, and so in Hadoop, MapReduce jobs, like you said, are specified as unsavory Java classes. So why is this a problem? I mean, certainly there's the multilingual difference. Are there other problems with the fact that you have to specify every MapReduce job as a Java class?
So the biggest problems I have with that is A, the multilingual problem, but B, the fact that it's a pretty heavyweight interface if you just want to do really simple stuff. So in Pachyderm, the way that a job gets data, and this is a really fundamental difference, is a job isn't an API that we call and push data into. A job is a program that we run in an environment where the data is available to it. And the data is available to it as a simple file system in Linux. And so what happens is your job will get started up in a container, and injected into that will be this special path /PFS that contains views into PFS data. And it can contain views into specific commits in the PFS file system. Just to expand on that a little, what's really powerful about that is that people know how to do a bunch of things just out of the box with like files in a file system. So for example, if you have just like a huge amount of data in PFS and you want to just grep through it to see find all the occurrences of a name or something, you can actually just use grep. And that job is literally just going to be spelled out as PFS run grep the directory where the data is, like /PFS/users. And that will now output, and that will run in a distributed way. We can distribute that across thousands of machines to just run this simple shell command.
So rather than using a Java API, you can just use the Linux command line APIs that we're all familiar with.
Right. And what's particularly valuable about that as well is that it makes development a ton easier. Because if you're trying to write Hadoop jobs, then basically the only way to test if your job works at all is to fire it off to the cluster and have it execute the whole thing and make sure that works. For us, if you're developing something locally, like you can mount in a PFS file system using Fuse onto like your local machine. You can actually mount it onto a MacBook Air. And you've just got a folder in there that looks like it has 100 petabytes of data, but it's actually networked and everything. But then you can actually run that grep just on local data in your own shell and see if it works. And the environments are just exactly the same because they can be packaged up in Docker containers. So developers are really just right in the front seat of controlling what they're doing with the system.
So what are the other advantages of using Docker? I mean, do you get any space advantages? Is it cheaper to use Docker containers rather than using the JVM?
I suspect that like for pure space advantages, I don't think that Docker quite really wins out there. Like I think that sort of the fixed cost of a Docker container is not notably lower than the fixed cost. Well, I guess actually, though, you don't need to spin up a separate JVM. And I don't know right now exactly what the memory footprint of the JVM is. Although, no, I guess when Hadoop MapReduce is running, you're going to still just have one JVM per machine. So I think that you might be paying a small extra fixed cost for using these Docker containers. However, there is one really, really big advantage that you do get out of this, which is that maintaining a consistent environment on a machine is actually one of the big challenges of running a Hadoop cluster. Because what always happens is, if you're the guy running the Hadoop cluster, you're getting this sort of string of emails from data scientists and people who want to do analysis that says like, hey, I just wrote, this job and I can, build this model locally, but it requires Python like 7.3 or 2.73. And, that's not what's installed on the Hadoop clusters. Could we get that installed on there? And then I've got another email from the guy who did that with Python 3.2, and like I can't have both of those installed on the Hadoop cluster at the same time. And this just sort of winds up being a nightmare because it isn't a fun job to basically just install dependencies on the 1,000-machine Hadoop cluster so other people can use them. This way, they're just completely in control of their own dependencies.
Right. So we have a super listener named Ivan, and he emailed me and asked me to cover some differences between Docker and CoreOS Rocket. I don't know if you have any knowledge about the differences between the two, but it would be a great opportunity to answer that question if you did.
Let's see. Differences between Docker and CoreOS Rocket. I have talked to both of... I'm fairly good friends with both Solomon and Brandon at CoreOS and Docker, and I've talked to both of them about the technologies. I think one of the biggest differences is sort of the Docker really tries to go for a server type of an architecture. So like they have the Docker daemon, which you just speak to through an HTTP API, even if you're running it locally. And then they also have like this notion of the registry that has its own protocol for like discovering images. Rocket, one of the big things they did that is different is you actually like pull images through DNS, and it's just like I believe the file transmission formats it's using are much more standard. Like I think you can just get stuff over HTTP. I mean that being said, you can do a very similar thing in Docker too, right? You can like package up images into tarballs if you want and just ship them around however you want. In terms of differences of like how I see these tools as a person who makes products out of containers, they're getting to the point where they're pretty isomorphic in terms of functionality, but I think that Docker is a lot farther along and a lot more polished.
So you just see them as like two different APIs to the same thing?
Yeah, I mean, I recognize that that's like a bit of an oversimplification. Like if you really dig into the details, there are those differences, but I think that for the majority of users is probably a pretty good way to see them. It certainly works okay for me.
Why is it an oversimplification? I mean, not to get too deep into the weeds, but I am curious.
I guess I'm more saying that I'm more saying that I think it's probably an oversimplification, just because I'm sure if you talk to those authors, of the actual people who are writing that code, they could tell you a million like architectural decisions that are different, and they'd have like very, very compelling reasons why these are actually important and they actually matter. They're just, I think, not quite things that I understand yet.
Okay, interesting. So let's talk a little bit more about the distributed storage aspects of Hadoop and how that compares to PFS. So what are the problems with the Hadoop distributed file system?
So in terms of data model, I think that the paradigm of having copy on write data is just sort of like a step up in terms of power, and I think it's a really big step up in terms of what people want to do. So that's sort of a feature difference, not a like quality of implementation difference, I guess.
So copy on write, that would be PFS's strategy.
Right. That is really the thing that, if there's one thing in PFS that I think really sets it apart and is really the new idea, it's this idea of copy on write storage for big data.
Because it pushes versioning. Right.
It pushes versioning. It allows these use cases to exist.
Right.
In terms of the actual implementation of the architecture, one of the biggest things looking at Hadoop that I didn't want to do was have an equivalent of the name node. The name node causes, I think, more pain than any other single component of Hdfs. And basically, the role of the name node is that the name node keeps an association between files, as a user thinks of them, and locations in actual servers that they can where those things can be found. Or actually, it might be an association from block names to that. There might be another layer of indirection in there. But the reason that this is a problem is that every single time that you want to do a write to Hdfs, you need to talk to the name node. And the name node is, you can't distribute it and have like a bunch of different masters for the name nodes that are all covering a different part of the file system. And so if you're writing a bunch of very small files into Hdfs, you wind up swamping the name node, and performance just grinds to a halt. And this gets really, really bad in a multi-user system where like one person is writing a ton of little files, and that just like screws over everybody's computations. So in Pachyderm, we have no equivalent of the name node. What we have instead is that we basically lay out all of our data into shards in basically a static configuration. And then for any piece of data that we want to store, we can hash the name of it, and we can go check in this layout information to see which server we should go to talk to. But because this is compiled down into just like a static data structure that's mapped out, we can save that in etcd and have this consistently available thing that's visible to everybody. And they can just go in there and find it. They don't have to swamp the name node.
Was this a home-brewed way of doing things, or is this like an implementation of some kind of research paper?
This is a sort of somewhat homebrewed. It's sort of a tweaked form of how Colossus does this, is what it's most similar to. And
what is Colossus?
Colossus is Google's HDFS. It's actually the second version of Google first had Bigtable, which is also called GFS, I believe. I may be mixing those up, but the second version of their file system was called Colossus, which is what's still in use today. And they lay things out in something that's fairly similar to this. This also is inspired heavily by the architecture that we built at RethinkDB, which was, I was one of the lead engineers on building out the distributed systems in RethinkDB, so I got to learn a lot of the sort of dead ends there. I got to learn where a lot of the problems are, and then Pachyderm was sort of a second crack at this.
Another thing you write about HDFS is that, quote, HDFS, I'm sorry, you didn't write this. Joey wrote this. So Joey wrote, HDFS is great for storing massive data sets in a distributed fashion, but it lacks one major feature, collaboration. So I think you touched on this earlier, but why, just to stress this point, why is collaboration so important for Hadoop applications?
Well, so collaboration is so important for Hadoop applications because inherently the way that companies want to use it always winds up being collaborative. It's important because you always wind up with multiple users wanting to use it, and without really strong collaborative primitives that are aware of the fact that there will be multiple users using it, they always wind up having to hack together solutions so that they're not stepping on each other's toes. Let's walk through a very concrete example of what something like this might look like in Hadoop and what it might look like in Pachyderm. So suppose I've got sort of a new data scientist, and I want him to develop some sort of a job that will like compute something about all of my users. So I've got my folder in Hdfs that contains like a daily dump of our production databases with users and all of the information I might want about individual users. Now this data scientist is going to go in and he's going to see this folder in Hdfs that's constantly getting updated every night with new information, right? That sort of gives him this moving target on which he needs to do his data analysis, and that makes his job a lot harder. So the first thing that he's going to do is he's going to make a copy of this, and then he's going to start developing his analysis on it. And this has already created a copy of the data that's now not updating, and they can sort of begin to fracture our data schema within Hdfs. Okay, so now let's go over to Pachyderm's world. This data scientist comes in, and we've got this user's data set that he wants to analyze. The first thing that he's going to do is make a branch, right? This is just like a branch in Git, where as soon as you create this branch, this is your own copy of the entire cluster. This copy of the cluster, it's never going to move forward unless you pull in results from somewhere else. This is your clean room. And he can do whatever he wants in there very efficiently with all of this data. And of course, like this is a branch that looks and feels like his own copy of the data. There hasn't actually been a physical copy of the data made. We haven't just doubled our storage capacities. And so he's now got this clean room that he can completely play around with. He can develop his job, and then at the end, it can be merged back in. And Pachyderm will support a merge process where people can see, just like in GitHub, you can have a PR. And you can have comments on, what this is going to do, and you can pull these into a separate branch and see how all of the new stuff and this will interact with each other, and that nothing's going to break. And then when that's all finally ready, you can merge this back into your mainline branch, and you can be sure that you have a master branch that's always functioning.
Right. And so this is essentially the same type of problem that you were talking about earlier with that Airbnb encountered.
Yep.
So
let me just add one more thing to that too. Actually,
sure,
which is that it's not just copying of data. Actually, a pretty common thing, and it's really at this point considered sort of a best practice in Hadoop land. Most companies actually run two entirely separate clusters, and they have sort of the one like production-ready cluster where for jobs to be deployed on that cluster, they have to go through like a really, really heavy review process to get in there. And then they have the other cluster where people can basically run anything that they want. And keeping these two in sync, or like keeping moving the good things from the dev cluster over into the production cluster, is this like huge manual process where what you really want is just the ability to control what's getting merged in and run where.
Right. So how does the PFS, the Pachyderm File System, how does this compare to Git?
That is a great question. How does this compare to Git? So Git really made a number of sacrifices. Git made a number of things that limited sort of the total size that a repo could be. First of this is, I believe, Git's sort of built-in diffing algorithm is using line-based diffing. And so this makes it really, really good for the use case they wanted to nail, which is source code. But it means that if you're storing binary stuff in Git, you frequently just degenerate down to storing a bunch of different copies of it. There's also the fact that, Git has no notion of like distributing out a Git repo across multiple systems. But the truth is that it's actually very similar to Git, and that's very intentional. There's this blog post that I absolutely love called, it's titled "Who Needs Git When You Have ZFS?" And it's this wonderfully, first off, it's this wonderfully humorously written blog post that I recommend to anyone. I think everyone will really enjoy it.
I'll put it in the show notes.
And it basically is this guy laying out exactly how you can implement all of Git's semantics using the ZFS primitives. And I read this article at some point, when I was thinking about what to build, what could possibly be the successor to Hadoop. I was already thinking about that question, but I had none of these notions of like copy on write storage or anything like that. And so when I saw this, I thought that's super, super cool. And if I put a distributed layer on top of one of these file systems, then all of a sudden I've got a system that is distributed, Git for huge amounts of data. And that just sounds really, really cool. That sounds like something that should definitely exist. And that was really sort of reading this blog post was, I think, that first like eureka moment where I started to see the system that Pachyderm is now.
Interesting. Let's talk some about cluster management. So distributed computing requires cluster management tools to let you manage machines that are used for data storage and processing. And Hadoop uses Yarn typically, which handles job scheduling and cluster resource management. And Hadoop also uses Zookeeper, which provides the highly reliable configuration synchronization. So how big of a weakness is it that Hadoop is so tightly coupled to Zookeeper and Yarn?
In my opinion, it's a pretty big weakness because those systems were they do what they need to do within the Hadoop ecosystem pretty well. This is not to say like the Yarn developers; those are of course very, very smart developers. They're very, very good, and they built the scheduler that Hadoop needed. But being able to use a general purpose scheduler just always opens you up to like letting it being a tool that is much more polished and many more people know, and being a tool that is sort of ready to be used by other things. Like you wind up with this very clean API if you use an external scheduler off the shelf. So I think that those are sort of some abstract high-level reasons of why this will be a weakness. The very, very concrete reason that I feel that this is a weakness is because now that things like Kubernetes exist, which is the scheduler that we're using, this is a scheduler that's written by the scheduling experts at Google. The scheduling experts at Google are, in my opinion, understand scheduling better than anyone else in the world. And they have built a scheduler that is incredibly powerful and incredibly just like gives us these incredibly high-level primitives to work with. And not being able to use that is a huge weakness.
So could you talk more about Pachyderm's solution to cluster management?
Yeah. So our solution to cluster management is to use off-the-shelf good cluster managers. So we basically right now we're deploying everything on top of Kubernetes, and we found Kubernetes to really just be the best way to schedule stuff. They give you a few very simple, very, very powerful primitives with which you can do whatever you want in with a distributed system, but which let us do exactly what we need to do. And so this really means too that like you can go in and see, if you understand Kubernetes, you basically understand how to turn all of the knobs within Pachyderm of like adding more storage, removing more storage, how you co-locate things. This is a really good example of this is in Hadoop. It's this very internal sort of magical thing that allows them to achieve data locality, right? Having a computation be on the same machine as the data that it's processing. In our system, data is scheduled by a pod in Kubernetes. It's located somewhere. And a computation is also a pod in Kubernetes that's located somewhere. And if you want data locality, then you use Kubernetes locality to make sure that these containers get scheduled on the same machine. And now you have locality. And that's something that I think is way, way easier for a user to grok and see what's going on. And the coolest thing about that is if users can grok what's going on and they can understand what's going on, then they can start to sort of tease it apart and see new functionality in there that we might not have known was important to them. I think that this is a lot of why Docker has been successful, is they committed to this batteries included but removable ethos very, very early on. And if you look at like what a lot of the killer features are in Docker right now, like the really interesting stuff with like volumes, like that, a lot of those initially came from users who sort of could grok the APIs well enough to start to tease them apart to add these things in for themselves. And those, were committed back to the open source project and got merged in and have really defined the direction of the project.
So are there any other types of cluster management tools that you see as promising, like Mesos or?
Yeah, absolutely. So we've committed to Kubernetes because I do think that Kubernetes is doing really good stuff, and right now that just felt like the right decision. But we needed to sort of pick one thing and go with it so that we could really produce something that works. And you can't. The one thing that you can't do is spend all of your time trying to make your system as open-ended and deployable as possible and work for a million different people but be great for none of them.
Sure.
But yeah, I think that absolutely Mesos is an amazing scheduler as well, written by people who are really know what they're doing as well. And we 100% plan to, when we have sort of a little bit more engineering resources, make Pachyderm into a first-class Mesos framework so that you can deploy it on there as well. And I think that honestly that would wind up being a very good scheduler for us.
Very cool. So let's zoom out a bit. Who is using Pachyderm?
So right now, Pachyderm is sort of seeing some use in academia and sort of in side projects and stuff like that. Pachyderm is, I'd say, still in the very early stages of adoption as an open source project. The people, to give you a type of person for the people that really are finding a lot of usefulness for it, first off, anybody who already has sort of grokked Docker and accepted that as a tool in their workflow and just thinks in terms of deploying their code in Docker, that's just a huge step of understanding Pachyderm and making it useful for them that they don't have to take, because they already know how to put these things together. They can really just think I've got this code in Docker, now I want to be distributing this over some data sets, I can just sort of throw it in there.
Yeah.
In terms, though, of the that's sort of a type of knowledge that you can have that makes Pachyderm more appealing to you. In terms of a problem that you can have that makes Pachyderm more appealing to you, it's anybody who has a data set, anybody who sort of has streams of data coming in that they need to log somewhere, and they particularly care about seeing how these things have changed. We've talked to a number of people who are interested in using this for genomic information. And I think a lot of the reason for that is that normally what you wind up doing when you're doing bioinformatics is you wind up sort of doing all of these transformations on these huge sets of genomes. And at the end of the day, once all these transformations have happened, it's really hard to track back the provenance of where this data actually came from. And when you have a system that's tracking this temporal state and how things evolve over time, the provenance is sort of baked into your data layer.
Totally. So one of the things that Joey wrote about was that it will be a while before Pachyderm has analogs for Hive and Pig. And Hive and Pig are extremely important to many companies that use Hadoop because they allow for easy query translation. A data scientist can just treat an entire Hadoop cluster like a single database with a Hive query or a Pig query. So what is the workflow like for a user who wants to run a query against Pachyderm today, and how do you think that will change in the future?
So right now, there really is just not a good story for how to run a SQL query against data that's in Pachyderm. The way that I think that that's going to change in the future is, my hope at least is we're going to go from a world in which we have a bunch of different competing solutions for storing data, we have Postgres and we have MySQL and we have all of these different things that have their own notions of distribution and they have their own replication protocols that they speak between their own nodes. I'd like to go to a much more generic solution where we can take sort of streams of data and we understand how to produce them and how to recombine them. And when you understand that, it will go from having these sort of distributed nodes that all speak SQL and talk to each other to being able to deploy in Pachyderm a bunch of distributed processes that each do processing of SQL on a small part of the data, output some intermediate step, and then there's another thing that knows how to combine those. And then you've created sort of a SQL engine that's agnostic to the distributive primitives that it's using. and you can use it on whatever distributed primitives you find that can be most useful. And so there's actually already starting to be some of this stuff for like very specific use cases. So like PG Shard is an example of basically a program that will allow you to take multiple Postgres databases and it will talk to each of them and stream data out and then recombine them such that this looks like one big Postgres database that you're talking to.
So if I'm a user that's locked into the Hadoop ecosystem, is there an easy way to migrate to Pachyderm?
Right now, no, there is not. And that is going to be a very, very hard problem because there are a number of sort of people and companies in the world that I would call Hadoop users. But if you go in and look at what they're actually using, you're going to see a very, very different picture in every single company. And so this is kind of going to be, this is the same thing that people always say about Microsoft Word, how there's a billion features and each person only uses 5% of them, but it's a different 5%. And so making the thing that can just migrate someone from Microsoft Word, unless you have all of those features, every single person is going to have that one thing that they think is super important that's missing.
Well, but on the bright side, things are pretty frothy right now, and there's so many new companies cropping up. I mean, if you can show that Pachyderm is decisively better for greenfield development, then people will just start adopting it.
That's our big bet. And I have a very strongly held belief that there are a lot more people who have the problem that Hadoop solves than there are people using Hadoop. Which is to say there's a lot of people who want to be using Hadoop that aren't. And the reason for that is just that Hadoop is a big cost to set up. I talk to companies every day who say, we have a problem that we think Hadoop is going to be our end state. Like as T goes to infinity at this company, we will be using Hadoop. But the costs are just too high right now. And that's 100% what I saw at Airbnb. At Airbnb, we thought we were going to set up a Hadoop cluster. We had one guy who's like, okay, go set up our Hadoop cluster for us the same way. It's like, okay, go set up this database, and now we have a database. 2.5 years later, this was a team of 20 people, and we still weren't quite to the point where we felt like, yeah, we're using Hadoop and we have it under control and it just works for us. You can't run a Hadoop cluster without this team of 20 people to basically just kick it when it falls over. And I think that if we lived in a world where if we lived in a world where running a Hadoop cluster was as easy as running a database, it would be open to an entirely new set of use cases.
I thought that was what Cloudera does.
Well, so we actually had a Cloudera contract when I was at Airbnb. I mean, Cloudera does make they make it easier, but it's still incredibly complicated what to do. So actually, to give you a little anecdote about one of the services that Cloudera offers, what Cloudera will do for you is they'll send you this little script which will tar up all of your configuration information for Hadoop and send it over to them. And what they do with it is they take it and they run it through this machine learning classifier that they've built, which classifies configurations as either stable or unstable. The reason they built this is because configuring Hadoop is so incredibly complicated that there's no human who understands what makes a configuration stable or unstable. We've actually had to resort to a classifier to solve that problem.
Oh. That's funny.
And so, yeah, Cloudera definitely offers you a lot of really good resources to make running Hadoop easier, but I don't think that they're solving the fundamental problem there. I think that to solve that problem, you really need a big leap forward. The analogy that I actually like the most for this is mainframe computers. So it used to be that computers were these mainframes that companies had in rooms, and there was no such thing as a PC. And at that time in the world, people sort of assumed that the idea of an individual owning a computer was ridiculous. Individuals had no use for computers because you couldn't see the use when it was impossible for them to use it. As soon as those costs came down and there was such a thing as a PC, turned out that, oh yeah, this is something that's useful to just every single person on the planet.
Right. So this show is part of a week of shows about Y Combinator. And Y Combinator is a startup accelerator that invests in the early stages of tech companies. Mm-hmm. I'd like to talk some about your experience in Y Combinator.
Yeah, absolutely.
What was the state of Pachyderm when you got into Y Combinator?
So the state of Pachyderm when we got into Y Combinator, actually, why don't I take this a step back and tell you the state of Pachyderm when I applied to Y Combinator and didn't get in.
Sure.
So I've actually sort of been in the YC family for forever. I've actually never had a real job at a non-YC company. Like I was a lifeguard in a non-YC company, but I joined RethinkDB right out of college, and then I worked at Airbnb after that. And so I knew from a very, very early stage when I was founding a company that I wanted to do YC. I wanted to do YC. I wanted to be part of that network. I just really aligned with them sort of in terms of their ideology. So when I first applied to YC, I'd been working on Pachyderm for about 3 months. There was no notion of copy on write storage. There was a notion of Docker, but it was more of an implementation detail than like this feature that was exposed to the users, and really the crux of it. But the basic pitch that I had for them was that this is going to be like Hadoop for the web, which sounds like a kind of lame pitch saying it now. But the basic idea was that this was going to be like the much, much easier version of Hadoop that like just a web developer who knows like Ruby or something could totally use to process data. And this was a good enough idea to get me an interview. And I went in, at this point I hadn't convinced Joey to join me yet, so it was just me. And I went in and told them this idea, and they rejected me. But they sent me a very, very constructive rejection letter. They said that they thought that this idea was totally on point, that the idea of there being a new Hadoop totally makes sense to them, that they thought I'd be better positioned if I had a co-founder and if I'd done more market validation on this and gotten something out there into the world. And so that was really the first moment where, before then I was in the mode of thinking of, this seems like a really cool software project, like I just want to hack on this, to, okay, this could maybe actually be a company. I didn't really believe myself yet that this was an idea that could have legs as a company until YC said that they thought the idea was on point. And that's really why YC winds up being so... Why founders just have so much passion for YC and are so invested in that network is that YC is just like the first person that believes in you, or the first organization that believes in you. So that was my first application to YC and my first rejection.
Just as a quick aside, do you think that's kind of a demarcation of an overall societal weakness that we feel a need to get picked?
I think that there definitely is that weakness. There definitely is the need, and the fact that people need this external validation. And this is something particularly in startups where you're kind of supposed to ignore this, or at least you hear a lot of advice that's like that. It's like, you're the founder, you have the vision for this company, you need to just believe in this vision even if there's a million people telling you no. But you really, like, I think to make progress in an idea, what you need to do is you need to have very strongly held ideals. You do need to stick to them even in the face of adversity. But if you can never get anybody to believe in this, then eventually you got to take a step back and think like, okay, maybe it's that I actually am wrong. And so needing external validation, I think in my opinion, definitely can be a weakness to someone who's founding a company. But you do eventually need it. And when you can find it in something like YC, and you can say, like, these people are smart and these people make me believe more, and I believe that they see things about this process and about this that I don't. You eventually need to sort of let other people into that circle of believers. I think there was this great post on HN recently that said that basically as a founder, what your job is to create believers. And that doesn't mean that if somebody doesn't believe, you're not doing your job, you failed, but you do somewhere in the world eventually need to be creating other believers. There's never been a company that went from like foundation to IPO with just your belief on it and still nobody else in the world believed. Obviously.
Right. Okay. So sorry to derail you.
No.
So once you actually did get into Y Combinator, did you have a part of Pachyderm built?
Yeah. So after I got rejected, basically, I took a step back. This was actually right around the time when I read that blog post, and had sort of the new upgraded version of this idea of, okay, we're going to build everything in Docker, we're going to have copy on write storage, we're going to have all of that, and then I basically just put my head down and built. And when shortly before our YC interview, we released the first version of PFS, and this had no computation system, no pipelining system. It was just a copy on write storage file system, and it was, I'd say, just sort of a step beyond a toy. It was far from a production-ready piece of software, but it got the idea across. And then we took this and we posted it on a HN, and we got not an outpouring of support, but we got some interest, and we got some people coming in and saying, this idea of copy on write storage, like this is interesting to us. We see how this could be a new and interesting direction. And that little bit of traction, even though an HN thread is not really much to hang your hat on, for Y Combinator, that actually has a lot more significance. And when we could go in and show, like, we have a GitHub repo, there are people who've come in and starred it and made comments on it, and we had this HN thread, that made the interview process really sort of a completely different conversation.
Interesting. So once you were into Y Combinator, did Y Combinator help you solve engineering challenges, or did they mostly give you like fundraising strategy? What were the things that the partners told you that were the most valuable?
So engineering challenges, not much. They really took that solidly falls under the heading of you're the founder of this company because you are an expert in these things, and like you're going to need to figure those out. A lot of what YC does actually is sort of force you to be honest with yourself. And that's actually one of the really hard things about running a company, is that you're so emotionally invested in it, and you're so just like tied to the performance that it gets hard to know when you're deluding yourself. Like something good happens, like somebody reaches out and they're interested in using the product, and this can be anywhere from like, okay, that's cool, somebody's interested, that's a good thing, to, oh my God, we just got a customer, we're totally set. And you get sort of a million different things in between this, and YC is very good about you come in, you tell them what you've accomplished for the week, and they'll say like, okay, that's good. That's actual something that's going to matter to investors. That's something that actually matters to you. This other thing, like, no, that's not good. That doesn't really count as progress. And just sort of forcing you to do those checks. The other thing too is there's just sort of a million different things in running a company that you kind of have to get yourself like thinking about it and comfortable with. So like one of the things that YC partners do is just every single week in YC, they come in and they ask you what your costs were and what you spent money on that week. And they're just doing that because a lot of people come in and they found a company, and suddenly they have this like pool of money, and they don't really spend it wisely. They don't really grok the difference between, this is the company's money that we used to build the company, not my money. And just like being those training wheels and making sure you don't make those mistakes is actually like hugely valuable.
What was the most counterintuitive advice that you got at Y Combinator?
What was the most counterintuitive advice that I got at Y Combinator? I think the most counterintuitive advice that I got at Y Combinator was the advice that I got from Paul Graham. So Paul Graham is kind of, I would say, emeritus from YC at this point. Like he's, you don't get like weekly office hours with Paul Graham. Each company gets one set of office hours with Paul Graham over the course of YC, and that's it. And so, it was like this big, like valuable thing, like, oh my God, we get to meet and talk to PG about this. And I was thinking that PG would have all of this advice about sort of the broad direction of the product and, where this company could eventually be. And in fact, he had the exact opposite. Basically, what Paul Graham said is like, okay, like the broad like goal for where this company could be, the idea of replacing Hadoop, like that's there and that's good, and that's a place that you would want to get to. Your biggest challenge is going to be staying alive until then. And so what he told what he told us to do is he said, basically, I want you guys to become sales engineers. I want you guys to just go out and talk to customers, and I want you to like not implement anything unless there's a very particular, like, this person is asking for this thing. And he wasn't saying like, this is your job now, this is what you'll be doing for the rest of the lifetime of the company. But he told us that we needed to do this right now during YC, so that when we walked in to talk to investors, we would have, this huge swath of customers that we could refer to talking to them about. And he also...
That's good advice.
Yeah, it was fantastic advice. And he also had us with companies, when we got to the point where we were saying like, okay, these ideas are making sense to the companies. This is really a product that they might be interested in. Unfortunately, we can't just magically over the course of YC complete a full Hadoop replacement with two guys. You just can't do that. And so we can't just sell them this product. But what we did do is we got them to sign letters of intent. And I had this totally walking into like the YC, I just had this attitude of like letters of intent are like sort of BS. That's sort of just like fake, not real revenue. It's like someone sort of is like too nice to say no revenue.
Yeah.
But that's not the way that investors think of them at all. Basically, what investors think of them as is this is a piece of evidence that removes one particular type of risk, which is just there's nobody in the world who even has the slightest bit of interest in this. And
right.
Even this, the difference to them between a product that you have a founder telling you this is going to be good, this is people are going to want this, to a founder telling you this is going to be good, people are going to want this. But I really wanted to check that hypothesis for myself, so I went and talked to these 100 companies, and these 50 of them didn't want this. These 50 of them did, and these 25 of them wanted it so much that they were fine signing letters of intent about it. That is...
It's 0 to 1.
Right, exactly. There's something to think about. There's some sort of evidence to consider for why there might be people out there versus nothing. And this is for every different type of companies. And one of the other things at YC, and this to be fair is I think something that YC is still figuring out, is what investors are going to want to see coming out of demo day to give a company like that initial seed round of funding are completely different vertical to vertical. And YC has been aggressively expanding which verticals it's really interested in. But it's still got the verticals that it really understands that are in its sweet spots, and the verticals that it doesn't understand as well. And so one of the great things is that for us, infrastructure is a vertical that YC is pretty good at. There are, at this point, a number of infrastructure companies that have come out of YC, CoreOS, Docker, RethinkDB, that are starting to really define the infrastructure landscape. So YC knows how to do infrastructure well, and so they could give us very real, actionable advice of like, look, guys, getting actual revenue by demo day, that's unrealistic for an infrastructure company such as yourselves. However, getting LOIs is totally realistic, and companies in the past in exactly this situation have been able to raise on basically that. And, it's insane. It's insanely loose. And also, I should really say about YC that this advice really also comes from all over the network. It's not just the partners. So being able to just call up another company from YC, another infrastructure company from last batch that had been in about a similar situation and been successful in fundraising, and just say, how exactly did you do this? Who were the first investors you talked to? Who really gets this vertical and is easy to convince? And investors are sort of these this wonderfully nested structure wherein if you can convince one set of investors, oftentimes that set of investors can then convince another set of investors, and sort of all the dominoes start to fall. And that's sort of exactly how we approach fundraising, and it worked really well for us.
Okay, that's funny. Okay, can I ask you one more question?
Yeah.
If Cloudera came to you tomorrow and offered to acquire you for $12 million, would you do it?
Absolutely not.
Okay. Is there a number?
So, sort of I went to the University of Chicago, so I have this sort of somewhat theoretical notion of economics, which would tell me that there has to be a number.
Yeah.
Though Maybe not, actually. If we're thinking about, if I'm thinking about myself as a rational person, I have a certain amount of value that I derive from running this company. I really like running a company. There might not be an amount of money that's more valuable to me than running the company, in which case, no, there is an amount. Yeah. That being said, as soon as you get to really running a company, it's not just you anymore in this decision. There's other people who have equity in this company and who bought into this company under the premise of look, we understand that this is your company, we understand that you have this vision, but at the end of the day, we are trying to make money, and if Cloudera makes us this huge offer, you have to take the money. That being said, I think maybe the more interesting part of this question is the specifics of Cloudera making this offer. And I think that if they came in and offered us $12 million to acquire us right now, I would basically assume that we're going to at best become some feature that they have us add back into Hdfs. And I just fundamentally believe that there's...
You don't think it would be like an Instagram acquisition where you...
No, I don't think it would be Pachyderm within Cloudera's running this stuff and they're the shell that provides support or something. I think that it would be, implement these features, or more rather just you're a distributed systems hacker who seems to know what he's doing, given that you've brought this system into existence. You could probably solve some of our problems that we have on Hdfs.
Oh no, acqui-hire.
Yep. Well, I mean, that's the thing. We raised it a valuation of 10. If you get acquired after that for a valuation of 12, you're basically getting acqui-hired.
Okay. Oh yeah, I guess I should have factored that into I should have factored the last valuation. See,
that's also with the particulars of that. Talking to all of our investors, if I don't think we have a single investor who's out there who said look, man, this is the opportunity. We put in at 12, at 10, this is 12. You're not going to do better than that growth wise. Right. I don't think anybody believes that.
Okay, that's funny. Cool. Well, Joseph, it's been a pleasure. The time flew by. It's great talking to you.
Jeff, man, thanks so much for having me. I really enjoy interviews like this. This has been a blast.